So how many of you love TypeScript? And how many of you love JavaScript? Not all. Strange. Okay, so first of all, who I am. If you don't know me, I'm Luca Del Puppo, a senior software engineer at Nearform. And if you don't know us, you can go to the booth over there, and you can win some prize at the end of the day. I love JavaScript and TypeScript. I probably you already understood that. I also try to run my YouTube channel, but I'm failing in the last year because I don't have time also to take care of it. And I also write tech posts for tech people. By the way, how many of you already are faced with something like this? How many of you understand what this does? Not many. Perfect. Today I try to help you to understand what happened when you open this kind of strange file. But before, let's start from why TypeScript can help our team. Just a short introduction, then I'll jump to the code because we are developer and we love code and not presentation. So, as you already know, help the team because you can express what the application does, how are the shape of your object. Then, if you write good TypeScript without any, okay, you can prevent error in production. You can make your team aware of the change. Maybe you have a junior developer that try to fix or maybe build something in a piece of your application, but in the meantime also break something in another part of the application. So if you write the good TypeScript, maybe you can catch this error before the production or maybe before your customer. And I know many of you love this one, add intelligence in your IDE. There are also many other things, but I don't want to spend too much time on that. When you start to work with TypeScript, probably the first things that the people told you is TypeScript is a superset of JavaScript. So all the JavaScript code is also a TypeScript code, but the TypeScript code not always is a JS code. And this is the strange things, especially for junior and middle developer. Because basically, it's difficult to understand where end one and start the other. So there is a part of TypeScript is just a magic inside of your editor, okay? Then what run in production and what is just magic that run inside of our Visual Studio Code or WebStorm or whatever else. Then what really increase our developer experience? Because yes, for me, TypeScript sometimes, in the majority of the case, increase the developer experience. But for some project, can be a pain in the neck. And last, but not least, if you are a good JavaScript and TypeScript developer, sometimes you need also to understand when you have to split the two code base. So sometimes you have a code that is too much dynamically, and it's difficult to handle everything using the type system. So what we want to do is basically create directly your JavaScript code, okay, and create the code in the best way possible for JavaScript, and then expose another part of your code that is the interface that you want to expose to the outside. And this is when basically you create the definition type of your library. This is the majority of the case used for open source projects that basically need the performance with the JavaScript. And if you already know all this point, probably you are a good TypeScript developer. Otherwise, you are in the path to become it. Okay, I know probably many of you already does this. So you are fighting with TypeScript code. And okay, I don't want to spend time today and I think of the problem the next day. But probably the result is this one. Okay, someone arrived the day after or 2 days after and say, you did something wrong. So After this small introduction, what I want to show you today. So today I show you all the part that is magic that arrive from TypeScript. So the part that after the transpilation of the code disappear, but can improve the developer experience of your application or library. We will see key of type of Muppet type, generics, conditional type, looping, and blah, blah, blah. What we want to see is JavaScript. I suppose you already know it and you are already a good JavaScript developer. So let's jump to the code. First, this is a small example on what we can achieve using JavaScript. So here there is a navigate method that accepts a string with basically a template with the URL and some parameter. And we want to have the second parameter that basically create the types based of the path that we want to basically call. In this case, as you can see, the path is a simple string with user / a parameter ID. If I use this ID, as you can see, this works as expected. But what happens if I pass something with an empty string, an empty object? We will receive an error from TypeScript because, as you can see from the IntelliSense, this parameter there is a required field here called ID, and TypeScript wants that parameter pass to the navigate function. And basically, this is why this works. For instance, in this part, we have another parameter, ID and name, and I forgot to pass the name parameter. And as you can see, we will receive the error from the navigate method. How we can achieve this experience using TypeScript? Basically, this is the code. As you can see, it is a 10 line of code, but not really simple to read. Are you agree with me? Okay. And this is where basically the majority of the developer struggle, because TypeScript is so powerful, but it's also so difficult to write in some specific case, like this one. Okay, then the navigate is pretty simple. It's a method that accepts a generic T of type string, and using the parse URL method, we can extract from this string basically the parameter required for this path. And then, as you can see, the rest of the code in this case is just a simple TypeScript. So the real powerful code here is this parse URL param that enforce the type of the params basically at compile and build time. Obviously, these parse URL params disappear at runtime. Okay, so if someone decides to pass an as any, the compiler doesn't check, doesn't take care of your parameter, and basically you will receive an error at runtime. Then, so how we can arrive to this kind of solution? Let's start from a simple basic part. So the first part is TypeScript has the powerful of describe all the possible types. In this case, as you can see here, there is a strange thing so that it's difficult to achieve in other languages. We have a type and a const with the same name. But as you can see here, the first line type welcome is a real TypeScript type that describes that the welcome type is a strict welcome to everybody. And the second one is a const welcome. This is a real JavaScript code, okay, that in this case match with the welcome type. This is where sometimes also junior developers struggle to understand TypeScript, because yes, what is const, what is type, because I can use the same name. Yes, you can enforce this kind of convention using ESLint, but basically out of the box you can do this kind of solution if you want. So first part is that with TypeScript, the first things to do is to be strict as soon as we can. So what does it mean? We can use a string, the real value of the string, as a type of our variable. In this case, I can describe the type state using the starting string. In reality, in this case, starting is not a real string, it's a real type. This means that the type is something that TypeScript can understand. So what happened? I can use also string if I want, but in reality, I'm not describing the state like I'm expecting. In this case, using also the pipe, I can create an union type of different literal type, okay? This means that the state for TypeScript can have different value, starting, running, arrived, retired, okay? But only once at time. And as you can see here, the const state has the starting value that match with both the string and the state value in the, types in this case. We can use literal also with Boolean, other kind of string, or also with number like 0, 1, 2, and blah, blah, blah. So we can, when you use TypeScript, try to be more strict as possible with the possible value of your field in this case. Then we have the literal type, and what we want to do, what we want to achieve in some case is to basically create other types that depend on this kind of types. So we can combine different types. What we can do is using the template, okay, the template syntax. How many of you already know the template syntax in JavaScript? We can use the same approach also with the types in TypeScript. What does it mean? For instance, we have two types in this case, state and runner. The state describes all the possible state for a runner, starting, running, arrived, and retired. And the type runner describes the name of the runner. What I want to create is basically a state, a type with basically merge the runner to all the possible combination between runner and state. And in this case, I want to do a runner status that is the name of the runner is the state. As you can see, in this case, we have 12 combination between the state and the runner. Using this approach, basically we can create many other types that depend on other types. Because it's important, sometimes don't lose the source of the type. And basically, if someone one day decide to remove a runner, basically out of the box receive the new types without spend too much time. Pretty simple. Then using the template syntax, we can also basically create other kind of template. In this case, for instance, the RGB color can be described in this way. So we have the first part is RGB, parentheses, number, comma, number, close parentheses. And as you can see here, JavaScript, TypeScript is able to understand, in this case, the format of the string. If I put an A here, color as an error, because the syntax A can be converted in a number. And as you can see, using all this kind of combination, we can have we can create many strict conditions for our TypeScript code. Okay, the two simple things has gone. Now it's time to talk about conditional type in TypeScript. Probably this is one of the most difficult part in the TypeScript code. Unfortunately, in TypeScript, we don't have an if statement for the types. What does it mean? We can use if else, but what we can do is basically create using a sort of ternary operator, okay, and a pattern matching, we can create a sort of if. In this case, I create a if statement using if, and I can pass as first generic parameter C, a condition that can extend true or false, and then other two other generic. The second one is for the true value, and the third one for the else. What happened? We can do basically in this case a type check of the condition to extract one or the other types based on our condition. This is pretty simple, so using the true, if I pass yes or no, I will receive a yes. If I pass false, using yes or no, I receive no. Pretty simple. But this extend and this syntax start to be complex when we want to extract types from other types, because probably you have another library that you are using, and you don't want to lose the types exposed by this library, or you don't want to create another types equals to that type just to describe your types in your TypeScript code. So, for instance, what we can do is another things like this one. We can create a return type condition. What is a return type condition? Is a generic condition type that accepts a generic. And using the extend, as you can see, in this case, we can check if the T extend a possible arrow function. I also add, in this case, another keyword, infer. The infer allows us to basically, if this T is an arrow function, please, in the R generic, in the R variable, please TypeScript put the return type of this function. And what I can do here is basically extract the return type of a specific arrow function in this case. Otherwise, I can return never. If you don't know, never is an empty value. So something that without nothing inside. As you can see here, return type at the end can be called with using a simple arrow function. In this case, the return type is a string, and as you can see, the return type return a string. If I call this one with a boolean, with an arrow function with the boolean return, the boolean is the result. If I call the return type condition using a simple boolean, the return is never. Luckily, return type is already implemented out of the box in TypeScript, so you don't have to implement it. You can directly use the return type if you want, but sometimes it's also important to understand what happened under the hood. We have the same approach also for the parameter. For instance, in this case, we have the parameter condition that accepts the generic T, and instead of taking the return type, we can take, in this case, the parameter. Using the spread operator, we can basically put all the parameter inside of the P parameter and return the P if the T basically match with the arrow function, otherwise return never. And the result is pretty the same. In this case, the arrow function has no parameter, and the result is an empty array. The same is for, in this case, is an arrow function with a number. And as you can see here, the return type is an array with a number. Or basically, you can do the same with another kind of function. Also, parameter is already implemented out of the box. But we can use the infer also inside of the string, inside of the types string. In this case, a specific template string. As you can see here, I can check if inside of a specific type, there is a specific template that I expect. In this case, I want to extract the RGB color from a specific string that has a RGB parentheses number, comma, parentheses, and blah, blah, blah. If basically the T extend this pattern, so I can also infer R and check if this part extend a specific type that I want. In this case, extend a number, because I want that the red is a number, the G is the green is a number, and the blue is a number. And as you can see here, the result is this one. If I call this with 255, I receive 255. If I call this with 255.00, I receive 255.00. Just a small tricky things. Here, there is a space. If you take a look here, this one, return never. and not the number. So what happened? If I don't match exactly what the result, the pattern I described, basically the result is not like expected. What we can do here is basically is also you can create in reality, we can remove the space and create another types that remove the empty space if exists. This maybe help us to have a result also with the space or without or with the space between the number and the comma basically. Okay, so this part is gone again. How many of you are already with an headache? Now there is the other part, the second part, a bit strange. As for the if and the condition type, we cannot do loop in the type system. So what we can do is just using the recursion. And as you already probably understood, recursion can do infinitive. We have a memory to expect. So what happens if you do a sort of types that can have multiple loop in the condition? Probably you can receive an error from TypeScript. TypeScript doesn't kill your editor, but at some point decide to kill basically the recursion and return an error directly if you arrive at this limit. So we have an example. So in some case, we have an array, a type array that describe, in this case, a different color in column. This is a user table that has a name, a different name, and a possible value. What we want to do is basically create a get column types that accept two generics, the list and the name. The list is the array the types that you want to basically check, and the name is the condition that you want to meet. In this case, using the extend, we can do a different pattern matching. So in this case, the list check, okay, if the list is an array, please insert the first element inside of first and spread the rest of the types inside of the rest. Then, using in this case, the ternary operator, we can do the first check. Now we have the first element. If a first extend, in this case, the type's name with the name pass in the get column function, and the value, we don't want to take care of the value, but this should be just an array. Return first. Otherwise, call again the get column with the rest of the types that I haven't checked yet and the name. At some point, or you meet the condition and you return the first, okay, or you probably complete the list and you basically return never. Okay. So the result is this one. Get column, user table, first name. We will receive the type, name, first name, and value. We can basically do the same with the role or the address. The role basically return the real column inside, and the address return never, because address doesn't exist inside of the user table. Then we can basically do also other kind of loop. For instance, in this case, we can also create a sort of append. So using an array, we can basically pass an array and another type and append inside of an array another possible type using the spread operator, or we can also implement a find in this case, or a simple filter. I don't want to go to dive because you can basically check everything from the repo if you want. Okay, and with that, we learn how to do condition and how to do loops. Then how we can work with object, because with object types in this case. Because what happened in the majority of the case is that we have an interface or a type, and we want to remove a property add the property, or maybe makes the things optional, or makes the things required. Out of the box, TypeScript already exposed for us many and many utility for doing that, but it's important to understand how that works. In this case, we have the interface person. As you can see, it's a stupid interface with the name, surname, age, gender, and blah, blah, blah. The first things to learn is the key of keyword. The key of allow us to basically get all the property of a specific interface or type as an union of literal type. As you can see here, if I call the key of the person, I have I receive an union literal type of all the possible properties. Then the first exercise to do is how can I re-implement the interface without rewrite the same interface using the mapped type and the key of. So the mapped type is this strange syntax that is like create an object in JavaScript, but you can say, okay, K in key of person. This means that I want a new types that have all the key inside of person inside of the key of the new person, and then using the person and the bracket, we can use the K again to put the same type of that key. The result basically is that the new person is exactly the same type of the person. I know this is stupid, but it's the first things to learn to basically create all the other utility types that TypeScript exposed to us. For instance, we can create the partial type. The partial type is just a mapped type that add the optional type to your type, to your key. In this case, the result is the same interface, but with all the property as optional. Obviously, out of the box, this partial type is called partial, and the result is pretty the same. We can do the same with the required. The required is just another type that remove the optional type in this case. So this doesn't mean that all the optional type now become required. Then we can also work with the read-only. So we can add the read-only. In reality, we can also remove the read-only. There isn't any utility that out of the box remove the read-only. But if you want to create this read-only, the remove read-only, you just need to add the dash before the read-only if you want. Okay, this is work. This is fine because now you can know how you can create new types. And but we have many other utility. For instance, we have the extract type. The extract type basically allow us to from a type extract some specific type. In this case, we can work with in this case literal types. So name, surname, and age. I want to get only name and surname. The result is basically this one. From person name, I receive the result that is name and surname. We can work also with the complex object. In this case, using the type, we can check if the pattern matching is the type property, and blah blah blah. Yes, extract is already exposed out of the box. You can use the exclude. The exclude is the opposite of the extract. So basically, instead of returning the value that match, we return the other part of the types. We can have the pick to basically get only some specific property from the types. The same is for the omit if you want to remove, and blah blah blah. I know if you are familiar with the TypeScript, you already know how this kind of stuff works. But what we can achieve using this kind of solution. So this is a person, and this is a get by key method. This get by key method accepts a type, an object type, okay, and allow us to do this. If I do go here and I do this, as you can see, the IntelliSense suggests me all the possible property inside of the types, but not only the first level of the property. If I go to policy accepted, I can also go inside of the nested object. So policy accepted dot date. How I can achieve this? Basically using all this kind of practice that we will see. Okay, the implementation of this get by key method is this one. I know it's a pretty, it's a nightmare to understand, so I give you the repo at the end. But we have two generics, the const t and the const k. K extend get all keys and nested keys. That is a specific types created by me in this case, that force the key using the possible value inside of the field of the types. And the get value by path basically add the type of that specific key. The result is something like this. This is the get all key and nested keys, accept the T and the prefix, using basically the extend, the exclude, looping, the infer, and a lot of nightmare, a lot of headache. You can basically create all the pattern basically directly from the types. And I don't want to go too much deep because we don't have too much time, but as you can see, for the developer experience, it's fantastic at the end because using the IntelliSense or during the build phase, we can get the error if something has changed. For instance, if I change the policy accepted here, I receive an error here because policy accepted date doesn't exist inside of the interface. Okay, if you want, inside of this repo, you can also go to the source folder, and there is a sort of fake query builder that accept, in this case, two table, categories and post, and you can create type safe query using TypeScript. In this case, c.id and c.category is not just string, but is something that you can achieve. Come on. Is something that you can receive from the IntelliSense. As you can see here, p.categories is a real literal type that I can use inside of this example. If I, for instance, remove the has, I receive an error because the alias p doesn't exist. Okay, you can basically check everything inside of the repository. Now it's time to close. Conclusion, what you learned today is that gymnastics is also good with TypeScript, but it's also a nightmare. I agree with you, probably. You can improve the developer experience of your project or your library, and you can help the team to improve the development experience and also prevent error in production. You can guide your team if you create the best TypeScript code possible, but unfortunately you have also some cons at the end. And another important thing, if you have a good TypeScript code, now you can also prevent the error before the production. Obviously, don't forget to test your code because yes, TypeScript is good, but test also your code is another good practice for your project. Then cons, obviously you need time. You need time to implement all this kind of stuff. You need knowledge and you need the time to maintain everything. So it's not something that all the company can do. And that's it. This is the QR code for the presentation. This is the QR code for the demo. And this is my contact. And thank you so much.